All right, folks, we're out here, coming out here to Pomona. Took some time to stop by Randy Anderson, Advanced Power Systems, fuel system guru, former world champion, top alcohol funny car, set up a lot of fuel systems for a lot of people. And he's going to kind of go over the steps of what he does when he flows a fuel system and kind of gives you some do's and don'ts on what goes on with the pump. So, Randy, go ahead and show us some stuff here. We got a pump taken apart. What are we looking at?
Yes, what we're looking at here is probably the most popular pump. It's a Waterman Little Bertha. This is a gear pump, much more efficient than a vane pump. A vane pump at a high RPM, probably by 9,000, is cavitating, not very efficient at the RPMs we turn today. One of the factors you have to do to make this pump efficient is you can see the modifications done. And this is nothing more than like porting your cylinder head. It gives it a smooth flow, and it also increases the time that the gear has at RPM. As it spins faster, you need to increase the time to fill the cavity of the gear, and it's very efficient then at high RPM. One of the things you got to do and look at when you get this pump and you decide to do the porting is when you put the thing together, these things have literally tenths of a thousandth in clearance. One of the important factors is when you put these pumps back together, you take it apart, you do all the modifications. You have to be careful when you tighten the cover. It really needs to be done gently in a crisscross pattern. Once you get this cover tight and torqued, before you do anything, you must put a 3/8 wrench on the back and make sure you can turn it smoothly. So many times you'll put it back together identically like it came apart, and you'll find that it's tight. And if you try to start the motor, it will eat the pump up. You will take the end plates out in the gears. Very important you do that. Far as longevity goes, these pumps are really, you treat them right, they last a long time. I would recommend after probably a year to 2 years of usage to take the snap ring apart. You will then press this bearing out. There's a seal and an O-ring. The outer O-ring, it's an 80-cent O-ring, but they do harden and will start to leak after a couple years, and obviously you can't run the car. So it's important that the maintenance be done. Obviously the other important factor is the gear size. You need to determine how much fuel you're going to use. This happens to be a 750 pump, but you want a pump that's going to be, close to the, amount of fuel you're going to run, so your bypasses are in a workable range. But a very, very good pump, very reliable, and take care of it. It lasts a long time.
What are some things that typically go away? Like you was talking about the after so many runs. Have you seen where is it the wear you see at on the end plates and the gears at?
Well, one of the things you're going to have to do after you run this pump a while, the end clearance, like on anything, will get looser. The coatings wear, and they will get looser. That's where I come in. You send the pump to me, and I will pressure check it. The thing I will find if it's not kept up is it will start leaking internally. So as the resistance pressure into the fuel system increases, it's going to leak on the end plates, and you're going to leak around the back. So the pump starts losing its efficiency. It takes runs to do that. It's very fixable. You take it apart, you narrow the housing. We're not talking much, 2, 3, 4 tenths. You'll pick it up to half gallon. Once they wear and you tighten up the end clearance, they're probably good for the next 200 runs. Once that coating's wore, once they've been certified and redone, then you have no problems. But it is something that needs to be done in the short future. Okay, what we got here is, again, the same Waterman Little Bertha pump. I'm going to take it through a series of different RPMs and pressures and check this pump. The thing you have to recognize about these pumps are they're positive displacement pumps, but if they start leaking internally, for instance, at 8,000 at 100 pounds, it may flow correctly, but at 8,000 and 150 pounds, you could start seeing internal leakage. And as an engine RPM increases and the pressure increases, you got to really pay attention to that. It's just not one pressure because you're dealing with a range of pressures. So I'm going to check this now, and we'll see how this is done. So at this particular deal, we're going to check it at about 100 pounds at 6,000 engine RPM, 3,000 camshaft. One of the things you have to remember when flowing a system is one of the most important aspects of this is the temperature of the liquid. The temperature is a big variance. I could flow a pump at 60 degrees versus 80, and you're going to see 3 or 4 tenths of a gallon difference just in the temperature of the fluid. So that's important. I've got a heater on this, and I always flow at a certain temperature. You really got to pay attention to that. So from wintertime to summertime, if you're not monitoring your temperature and it is significantly different, you're going to get completely different readings, and they're not going to be accurate. Okay, what we have here is the complete fuel system. We've done the fuel pump check, and it's passed. We've run it through a series of RPMs and pressures, and the pump has been deemed okay. There are times I get in here running it through a series of tests. It then needs, if it's got internal leakage, it will then be taken back off the bench, be disassembled, and then generally the housing has to be narrowed. Again, we talked about that, and that will tighten up the in clearance. It will then be pressure checked, and when deemed good like this one is, now you see a complete fuel system. So now we're going to run it through a series of RPMs, and we're basically, what we're trying to accomplish here is we're not only going to see what it flows at a certain RPM and get the pressures, but we'll doing it through a series of RPMs, we're going to actually map out a fuel curve. This fuel curve will be based on what you're trying to accomplish on the type of blower in your application, the RPM this motor is going to see. In this particular fuel system, you see the 3 check valves. And what you have is you have a pump saver, which only works when the throttle's closed at higher RPM. You have your idle check, which the main jet runs through, and this is your high speed. The high speed is what is critical and will tailor the fuel curve. This high speed will open at a given RPM based on the pressure in your poppet, and then the jet will determine how much it flows once the poppet opens. So now we're going to run this fuel system, and we're going to do some mapping, and we're going to see what we got. So what we're looking at here is we're looking at 2,700 next camshaft speed. So you double that obviously for engine speed. This particular fuel system right now at this RPM has 9.4 gallons in it. Obviously, you know, we're running a test, so the temperature's not normally what we flow, but it's at 74 degrees. And the pressure at the hat at this RPM is approximately 42 pounds at this given RPM. So we'll run it through. Once this test has been run through at all these RPMs, I will then map out the curve itself through the RPM. And at that point, I will then make the necessary changes, knowing what supercharger he has, to tailor this fuel curve to get it right so it will run correctly through the wide range of RPM. Okay, now we're done with the fuel system. It's been mapped and the work is done. We will take the fuel system off. One of the things we're going to talk about is care for the fuel system. On a methanol fuel system, it's a very corrosive fuel. So care in between races or after the race is critical. It's important that the system be flushed out of methanol if the car's going to sit any longer than probably a week. It needs to be done. The product I recommend using is, once it's been flushed out and the methanol has been rid of the fuel lines, is a silicone pump lube. In NHRA drag racing, we have fuel check in our particular application. So this here in small amounts will pass through fuel check. There won't be a problem. I highly recommend it. If you're running an outlaw class in fuel checks, not necessarily, you can use marble mystery oil. You can use any type of a thin lubricant. It's important that you run some through the pump and you're rid of all methanol through all your lines.
And also the barrel valve.
And the barrel valve. You know, again, yeah, the barrel valve, you need to put some in the barrel valve and move it and know that it won't stick or corrode. But with general maintenance, these fuel systems, once they're set up and done, they last a long time.
Okay.
Okay, we're going to talk about nozzles next and bypass peels. When you choose a nozzle, you really need to be careful what you select. This particular nozzle is a 60 thousandths nozzle, meaning it's got a 60 thousandths hole. This nozzle, as you can see, the orifice is much larger and then steps down to your hole size. This hole determines the amount of fuel flow, or supposed to. But the problem with this nozzle, it's got a very sharp square corner in the bottom. So really what determines the flow on this is not necessarily the hole diameter, but the corner down in the bottom. So depending on how fast the drill bit was plunged and how sharp the bit is, this nozzle itself can vary significantly in flow.
So a pin test wouldn't...
A pin test isn't necessarily going to tell you because it's internally and there's a corner. What we have here is a different style of nozzle. It too is a 60 thousandths diameter, but the difference between this nozzle is that the diameter of this hole truly is the restrictor, and there are no corners because it's got a radius entry. And now what you'll notice is with this radius entry and this 60 thousandths nozzle too screw in, even though the hole's diameter is the same, this particular nozzle will flow 11 to 12% more fluid through it than this particular nozzle. So you got to know what you're working with when you do it, because obviously one to the other is drastically different and can cause, extensive engine damage. You can't just go from one to the other. We're also going to talk a little bit about bypass pills, and these are no different. What you're looking at is a standard bypass peel. It's got a square back. So truly this radius here, this corner, is going to determine the flow. You literally can take your fingernail, flow this bypass peel, take your fingernail, roll it sharply for a little bit, put it back on the bench, and you may change the flow 0.05 of a gallon because that corner is really a determining factor. Today's bypass peels have what they call a chamfer back. This is no different than what you saw on the drop-in. So truly, with this cone chamfer in the back, this diameter is truly now the determining factor of what it flows. There are no corners that are going to, be the deciding factor. Again, this particular bypass peel versus this one, you're talking 11% different in flow. So you need to know what you're working with, and you need to be careful when you make your decision and choice of what you want.
All right, folks, and if you want to get hold to Randy Anderson, he's the guy I trust for all my fuel system work and has done a number of championship winning cars over the years. Just give him a call and he'll give the same care and attention to your fuel system.